one this afternoon, and then I've got same thing tomorrow, just because I've been having a hard time with the integrals and with the not necessarily the antiderivatives of a single function, but when you do the u substitution, so that chain, essentially the chain rule backwards.
Yes.
That's been giving me a really hard time. So that's why I've been signing up for 2 a day, and I know that our exam is coming up this week, opens up on Thursday. So I think that means all the material up until Wednesday is kind of like free game on the exam.
Okay. Okay. Yeah, I'm not even sure exactly how far through we're going, but I was wondering about that too. It's a lot of material, actually.
Yeah. So there's actually, there's a gal that I'm going, she's tutoring me tomorrow evening, but she said that she was the TA for this class last semester.
Okay.
So she kind of explained it to me. That's why I signed up for her again. But she understands, I guess, how the class is scheduled. And anyways, she said that like right now we're learning, each day we're learning one concept, then you practice it, then you have the homework type of deal.
Yeah.
But she did say that in the future weeks, like closer to week 6, 7, and 8, and towards the end, that it speeds up a lot more, and we'll be learning maybe 2, 3 concepts a day.
I feel like you're going pretty fast. Wow. Okay.
So I mean that was kind of like, I opened my eyes, got the bug eyes too. And so I was like, uh-oh, I need to keep up my game.
Yeah. Okay, well, why don't we look at that activity if you haven't done it yet?
Okay, yeah.
Go through it together, and then yeah, going from there.
Awesome.
Do you know how to share a screen with me?
I had no idea that was possible.
Okay. All right. Okay, so yeah, I'll teach you how if you want to do that. I mean, you can read off. I don't want to go back into the activity because I'm afraid they're going to like count it as a 0 and may have to do it again.
Oh no! Do you mean like taking the little quiz?
Yeah.
So no, it'll always take your highest score.
Oh, okay.
If that makes sense.
Okay, it does. It just scares me.
Okay. So, so we'll be doing.
Okay, so
Let me see.
So this is Tuesday.
Yeah, so it's day 2 of week 4.
We're looking at Prep A or Prep B?
Prep A. Okay. So I just opened it right now. And how do you share a screen? Is it on one of these tabs on the? I see it. Share screen. Screen share.
Yes.
And then I want to select my entire screen, right? Yeah.
Yeah, that would be good.
Okay. So right now, this is what I'm. Are you able to see that?
Huh? Yeah.
Okay.
This one's not bad actually, because you're just plugging it into your calculator.
Oh, okay.
So it's really nice. The funny thing is, though, I still got 3 out of 5 wrong, and I had to write her and say, "Can you correct them?" Which she did.
Okay.
But I don't know how you get it wrong when it's a calculator answer. So.
Yeah, I'm not sure. So it's just plugging it in. So it's e to the -3.
Well, that's exactly right. That's exactly right, Calvin. So the slope of the derivative of e to the x is e to the x. So the slope at -3 is just going to be e to the -3.
Okay, got it.
Yeah. And you're rounding it. Just look at what they say to round it to. I think it's to the hundredths place.
To 4 decimal places. So
excuse me. I'm going to grab some water.
All right.
That's all you're doing on that one. Okay. Okay, you doing okay?
Yeah, so that one should be, looks like 0.0498.
Okay.
So I guess, so for these questions, are we taking the derivative and then plugging in our x value?
Yes, but the derivative is the same, right?
For e to the x, exactly.
E to the x, and so I think in all of them were e to the x, weren't they?
They are, yes. So it's really just essentially the same
Yes.
value. So this 1 to the negative 1 should be 0.36. And then e, oops.
And anything to the 0 power is 1.
Yes.
I wrote 1 there. I wrote 1.0000 there. And they would.
And this tells you that it's wrong.
Yeah, it didn't matter. So just so you know, I mean, you can, maybe it will work for you. Maybe it's just mad at me. But if it doesn't, I would just go ahead and write Professor Carlisle and say, here were my answers, and it didn't give it to me.
Okay. So e to the 2 then is 7.3891. And e to the 4th, which is 54.92. Whoops. 2. Okay. See what that does. Yeah.
So the same thing for you. Yeah, I don't know why.
Okay. Well.
But you're right. So just write her. She'll give it to you.
Okay. Yeah, because I keep doing I kept doing all the same things on a lot of my prep quizzes. It's been telling me that I miss a ton. And instead of wasting the time, like, I mean, it kind of sounds bad. Instead of wasting the time to see if I did something wrong, I've been just kind of letting it go because it's kind of frustrating if it's just, even if my answer's right, but it's just not written the way that computer likes it or whatever it may be, that it
exactly
accept it.
That's kind of what I've been doing lately too. They said try 3 times, and I was doing that for a long time, and now sometimes I try 3 times, but if I think I really have it right, I go ahead and just tell her.
I saw it out.
Calvin's doing a screen share with me right now, honey, so I see a screen, not him. Okay.
Okay, so for this one, now it's the same.
I think I got 100, so I think that one worked.
Okay. So, but however, for the derivative of our natural log x.
Right. Is what? What's the derivative of natural log of x?
I believe, I can't remember the rule for the natural log. Do you have, sorry.
Yeah. The derivative of natural log of x is 1 over x.
It's just 1 over x. So you bring that x out in front, or what's the technical, I guess, the step or rule?
So it's 1, so the natural log of u, the derivative of that is 1 over u times the derivative of u. But in our case, because we're dealing with x, the derivative of x is just 1.
Yes, and then
1 over x times 1, or just 1 over x.
Yes, okay. So 1 over 1 is 1.
Right.
And then natural log of x. So 1 over 2, just 1/2.
They round to 4 decimal places, so I think I did write, like 0.5000. I want to say.
Oh, okay.
That kind of thing to get it to work. It seems like that's what we did. I can't remember for sure. I think I first did a fraction that didn't work, so then I did a decimal. I don't know.
Okay.
One of those. We'll figure it out.
So the graphs for the exponential functions. Oh, that's talking about the worksheet, I believe.
Yeah.
Okay, so I'll have to just take a look at that after. Okay, there we go. That's what I was looking for the 4 decimal places after. Okay, so I guess, so the idea of this worksheet, if you will, let me see if I can. Okay, so the idea of this activity is kind of now we're going over the derivatives of natural log and log functions.
Yes.
Okay. And so for natural log of u, our derivative is
so this isn't the one she was referring to in that quiz, but can you see this? You want that. So more on derivatives of logs and exponentials, and it has there a great list of functions and their derivatives. So e to the u, natural log of u.
Yes. Let me see if I can.
And then it asks you to do some practice problems. And I wish it had on here where to find that. It doesn't. I'm sorry. But it is in this week's work, I'm pretty sure.
What was the name of that worksheet?
More on derivatives of logs and exponentials. It's probably today or tomorrow.
I believe it was today. Let me see if I can. I should be pulling it up right now.
And so I'm confessing here what I do, but I typically will print off the worksheet that has the answer key on it.
Yeah.
And then just cover up the answers and do the work on my own, but that way I have immediate feedback on how I did.
Yeah, usually I'll have that, and I'll have the same thing of the other browser bar that pops up with the answers, and so I can give it a try and then see exactly. Oh, okay, perfect. That's what I got, and then
or I made a mistake.
And then I use the tutoring that I go do at least once a day. I use that to, if I'm not getting the answer and I'm not understanding why, then I go use that for an explanation, which has been really helpful.
Yeah.
I found a different worksheet, but it shows that it's me. It was one that has like a couple boxes with just some values to be able to fill in.
Okay. It doesn't have any practice problems on it or anything?
It has a couple, but it does not look like that same worksheet that you had. Is that, do you know if that was for Tuesday's assignment or for Wednesday's, day 3?
I really don't know, I'm sorry.
Oh, it's okay, I'll take a look. But
what I've been doing, honestly, is pretty much printing out the week's assignments and then just kind of working as I have time.
As you have free time? Okay, got it. I do have a couple questions, or a couple. I wrote down a list. They were from homework problems in my math lab. Just to try and practice. It's just that the integrals and it's with the u substitution, and that's what I feel like it's really giving me a hard time, or it's really killing me.
Okay.
Okay, so like one example that I have. our two problems here. One was with the integrate, it was 2x and then parentheses x squared plus 3 cubed.
Yes.
Yeah.
Okay. All right. So are you figuring out how to say, okay, this is what U is?
Yeah, sort of. So after today, tutoring today, so it kind of, typically it's whatever's in the parentheses, I've noticed, but he said whatever you can get to make so it cancels. So x squared, its derivative is 2x. So, and that will cancel with the 2x on the outside, essentially, he was saying. Mm-hmm. So it says you want to use, if you can see that immediately, then you know there's your u.
Mm-hmm. Yeah, so my derivative, that's what's really important. So I'm looking at, the x squared plus 3, and I'm going, okay, well, the derivative of x squared plus 3 is 2x. I actually don't care about that constant, Calvin. I can manipulate the constant.
Yeah. So
what I'm really worried about is the power. So if it's x squared inside, I need the power to be x to the first outside. If it's, so that's where I'm looking for the u and du there, is I'm looking at that power. What do I want it to be? So yes, good. I mean, your thoughts there are right on, but just so you know, the constant is not really that big of a deal. We can manipulate it.
Yeah, so the constant's not the big deal, but it's that, like you said, so it's the power. So since that x squared in the middle is to the second power, obviously, and then, but I need that squared to match the 1 power on the 2x on the outside.
Right.
Okay.
So you're gonna set u. You're gonna write u equals x squared plus 3.
My u equals my x squared plus 3. So my du is equal to 2x.
Don't forget your dx.
Dx, right.
2x dx. Okay.
Okay.
Yeah, and so then you're going to go back to that original problem.
Mm-hmm.
2x dx becomes your du, and the x squared plus 3 becomes your u. So you're just going to plug that in. You have the integral of u cubed du.
Dx. Okay. So now.
So you want it all in terms of u. It should read u cubed times du.
Oh, is it times du? Not dx anymore?
No, because you let du equal 2x dx. So where are you in the original problem where you had 2x and dx, now that becomes du. Does that make sense?
Yes.
Remember, multiplication is commutative, so I can put it wherever I want. I can put that 2x dx together and put that x squared plus 3 cubed together. So 2x dx becomes du, and x squared plus 3 becomes u.
So I have 2x times u cubed times du.
Mm-mm.
No. Oh, sorry.
You're okay. Here, I'll try and share this with you, okay?
Okay, yeah.
I've got 2x times x squared plus 3 cubed dx.
Yes.
Is equal to x squared plus 3.
Uh-huh.
Du is equal to 2x dx.
Yes.
So where I did have 2x dx, now I have du. It's gone. I want it in terms of u. I don't want x's.
Got it. So, okay. So 2x times dx, that's the same thing as du.
Right.
So that really essentially equals, so it's the integral of du times u cubed.
Right. Or u cubed times du is how you usually see it, but you're fine. Du times u cubed is the same.
Okay.
But I can integrate that because the integral of u cubed du is just u to the 4th over 4.
Okay. So I have, now when I integrate that, my du goes away, and so does the integral sign.
That's right. I have to have du there, in fact, in order to integrate it. That's right. So when I integrate it, right, du is gone and the integral sign is gone. I've done it. I've integrated it. So now, yeah.
Right, so it becomes u to the 4th over 4, and then it's just plugging back in the actual value or the actual thing that was that u equals.
That's right. And don't forget your plus c, because remember that a derivative of a constant is 0, so there could be some arbitrary constant that's added.
Okay, so x squared plus 3 to the 4th over 4, and then plus c.
You got it. That's it.
Okay. That makes sense, and that was supposed to be the answer. The other one that I was kind of looking at was when I start, the square roots were kind of tricky for me.
Okay. And typically speaking, whatever's underneath the square root is u. That's not always the case, but typically speaking.
Typically, okay. So same type of problem. So it's taking the integral, integrating. So it's 3x to the 4th over the square root of 7 minus 6x to the 5th.
Okay. And so again, not worrying about the constant. If you look at the x to the 5th power versus x to the 4th power, you can see I want u to be what's to the 5th power, what has a 5th power, and I want du to be what has a 4th power.
Uh-huh.
Okay. So I'm going to let u be what's underneath the square root.
Yes. So my u equals the 7 minus 6x fifth. So my du equals negative 30 x to the 4th times dx.
Right. Okay. So you can do it however you want, but I always tell my students to take the constants out front and just don't bother with them.
Okay.
So that 3x to the 4th, I'm going to put a 3 out in front of the integral and just have x to the 4th on top over the square root of 7 minus 6x to the 5th dx. Does that make sense, or do you want me to show you what I have written down? All I'm putting the 3 out front.
Yeah, so 3x to the 4th, and then all I have is...
So I would rewrite it like this. So I have the 3,
Yeah.
3 in front of the integral. Same thing, I'm just putting the 3 in front of the integral because I can integrate something and then multiply it by a constant, and that's the same as integrating it with a constant inside.
Yeah.
Okay?
So now that I have taken the derivative of u, though, so my du,
Right.
can I place that negative 30 x to the 4th dx under the square root?
No, don't do that. Okay, so you have an x to the 4th dx in your numerator.
Yes.
We want x to the 4th dx to be in terms of du. Okay?
Uh-huh.
So we're going to take that du equals negative 30x to the 4th dx, and we're going to get x to the 4th dx by itself.
Okay.
Okay? So how do we do that?
So get x to the 4th dx by itself, so we would just divide du by negative 30.
Exactly. Which is the same as multiplying it by negative 1 over 30.
Yes.
Okay? All right.
One of my friends who lives in Idaho.
So, again,
Sorry,
I know this is kind of tricky this first time coming, but I think it will come together. Okay, again, that's a constant. Negative 1 over 30 is a constant.
Uh-huh.
So I'm going to bring that outside of my integral sign. So in front of the integral, I'm going to have a 3, and I'm going to have a times negative 1 over 30. And you can simplify that, but we won't worry about it right now too much.
Okay.
So negative 1 over 30 times 3 will be outside of my integral.
Mm-hmm.
Okay? And now that I've taken care of all those constants, okay, I have that x to the 4th dx is just du. I can write du on top. And on the bottom, I have the square root of u. because it's just the square root of 7 minus 6x to the fifth.
So
It's much harder to explain this, I think, over the computer than it would be in person. Sorry.
it's okay. So I've got my -1 divided by 30 times my 3 on the outside. And so what we're going to be taking the antiderivative of, or integrating, is actually x to the 4th. Correct?
No. Let's
To make,
no, you're not.
to make that x to the 5th on
No.
the numerator. No.
No. It's okay. Let's kind of start over again. All right. You were okay with me taking the 3 out, right? You got that. If I take the 3 out, I've got x to the 4th dx in the numerator, and I've got the square root of 7 minus 6x to the 5th in the denominator.
Yeah, so
So make sure that that's okay. We're just going to do baby steps here because I think it's nicer.
Yes.
You're okay there?
Uh-huh.
Okay, and then you let u equal 7 minus 6x to the 5th. So du is going to equal -30x to the 4th. You're okay there? Just make sure that it's not just words here.
The 5th. So, and then my du equals, yes, -30x to the 4th. Yes.
Okay. Okay, so what I did is I said I'm going to multiply on both sides by -1/30. And when I do that, I'm going to get -1/30 du is equal to x to the 4th dx.
Mm-hmm.
Okay, so just make sure we're on the same page there.
Yes.
That's okay.
Uh-huh.
Okay, now I'm going to go back and substitute. Where I had x to the 4th dx, I'm now going to have -1/30 du. Where I had 7 minus 6x to the 5th, I'm now going to have the square root of u. Okay, so this is what that problem should look like, and make sure you get it.
Okay, so
Integral -1/30 du over the square root of u. Do you see that? That's the most important part. When I make that substitution with u, I can't have any x's left.
okay.
There cannot be an x in that problem.
130. Oh, okay. I see what you're doing there. So 3, and then it's the -30 du over the square root of u.
Right. And so what I'm saying with the constants is, go ahead and take that -130 and bring it out front too. So you just aren't worrying about it. You're not thinking about it. Take it out front. So it's 3 times -1/30, which is -1/10 if you want to go ahead and simplify that. Okay, du over the square root of u. Okay, so I have it right underneath where I had written.
Yeah.
Okay, we're okay there?
Yes.
Okay. I always think it's easier to bring everything into the numerator. So the square root of u is the u to the 1/2. If I bring it into the numerator, it's u to the -1/2.
Uh-huh.
Okay, so I'm just going to write this as, I'm going to simplify that out front to -1/10, and I'm going to write this as u to the -1/2 du. So please, if you don't understand that, ask.
Mm-hmm. No, that makes sense.
Okay. So now I'm going to integrate it. When I integrate u to the -1/2, it becomes u to the 1/2. I'm adding 1 to the power.
Mm-hmm.
Okay, so 1 plus -1/2 is 1/2.
So the square root just moves up top and then times du.
Right.
-1/10 on the front. So now that you've integrated, though, the du goes away, correct?
Right, once I integrate it, once I add 1 to that power and then divide by what I got, which is 1/2, or multiply by 2, it's the same.
So we do, so then we have negative 1/10 times the square root of u, which is 7 minus 6x to the fifth.
Okay, but you need to be dividing by 1/2. If you take u to the 1, remember when you add 1 to that power, you also divide by what you got.
Got it.
Remember u to the n plus 1 divided by n plus 1?
Yes.
Okay.
So that's over 1/2, so essentially that's like multiplying that by 2, so it's negative 1/20 over 20.
I'm multiplying by 2, not dividing by 2. When I divide by 1/2, it's the same as multiplying by 2. So it would be the same as negative 1/5, not negative 1 over 20.
Oh, yeah, I'm sorry. Okay. Yeah, you're right. So negative 1/5. Then times the square root of 7 minus 6x to the fifth.
You got it. Plus c. Don't forget your plus c, or I'll count it wrong.
Ugh, goodness gracious.
It gets easier, I promise.
I don't know why. Just been the derivatives and everything else has been very clear cut, if you will, but this has been. I don't know why it's so hard to substitute something and then wait, and then take the integral. I'm not sure. But I think that will just get better with more practice.
It will. It will.
One more quick question. So kind of what we've been going over this past week has been really our integrals. Those are, oh, sorry.
Yeah, I wish you would kind of do a review sheet that said, here's what I want for exam 2.
Yeah, remember that this is what's going to be there. So as the integrals, antiderivatives. We had today the homework, what was it called? Okay, here it is. So we did some initial value problems.
Related rates. That wasn't on the last test. Integration, indefinite integration and definite integration. Substitution. Yeah, optimization problems. I don't think that was on there either.
That was not on the first exam, correct?
Yeah, I think that's going to be on this exam. Tangent lines, linearization, I'm sure will be on there.
I thought we had a question on exam 1 about the tangent line.
We did, but we continue to do stuff with the tangent line, so it wouldn't be surprising if she does something with it this time either.
That's true.
Area between curves.
That's just what we went over today, right?
I'm not sure if it was today or not, I'm sorry.
I
know we've done it.
I think the videos that she posted on iLearn, those are for today's activity.
Yeah. Implicit differentiation. I mean, I assume anything's game that we've learned so far.
Yeah. So I guess we did that's right. And even the chain rule derivatives were still, from what I'm looking at the homework, was after the first exam as well, I believe.
Okay.
Even the chain rules, so I wouldn't be surprised if there's a lot more of that. So we have the kind of really the material that'll definitely be there. The integrals, whether it's indefinite or definite. So integral, if it doesn't need a u substitution, it's just going to be the antiderivative of something, and that's the indefinite form. And then, but if it's definite, it'll have the, what did they say? The bounds.
Limits, yeah.
Or the limits with the numbers, and then that's just plugging those two numbers in after we take the antiderivative or integrate a function. We plug those two numbers in to see what the values are.
Mm-hmm. The top subtract the bottom.
Yeah, sorry.
Yeah, yeah.
Okay. And then our initial value problems, the homework that was due at noon today, that one it was pretty much our integrals, except for integrals and u substitution, except for we were solving for the value of c as well, from what it looks like, or from what I was working on today.
Okay.
I'm pretty sure that's how that was going. The optimization, that was last week when we had our meeting as well. And that one, I guess, was a little bit troubling for me. There were 3 problems of optimization that she gave us. The one with the box.
Yeah, I've got it right here.
There was one with the box. There was one with distance related to a triangle and then a straight line.
Oh, maybe I don't have that one.
That was the one on the homework. So there was I guess the homework problem said that there was somebody on an island right next to shore.
Yeah.
And it gives you the length horizontally until shore, and then but tells you how fast she would row at a diagonal pace, and then the point from the horizontal line until town. So you have to figure out the length and what are the distances. And then the other problem was darn it, was just the falling speed of something, the acceleration, velocity and acceleration.
Yeah, so I have a worksheet called optimization problems, but I'm not seeing that specific one, but I do remember doing it.
Yeah. I think those were the 3 types of problems that she threw at us. So I'm expecting, obviously, that
we might have something like that on the test.
Yeah, so she wouldn't throw something at us. So those, for optimization problems, the box.
Was that on the My Math Lab? Was that?
Yeah.
Okay.
Well, those are the questions that I remember exactly.
Oh, okay.
So doing the optimization for the box, that one has a specific formula. The one for the distance, if it's a triangle and then another length, that one has a specific formula. And same thing with the speed, velocity, and acceleration, which is the t squared minus something t plus a constant typically. And then you take derivative and then a second derivative. First derivative gets your velocity, second derivative gets your acceleration. And then I believe you're just plugging in values depending on if they ask you for certain points. But those are the only. Do you know if she gave us, if there were Were there any other types of optimization problems that she gave us that we would have to use a different?
Give us a worksheet on optimization, and so it had the box problem. It had a couple box problems.
Okay.
It had a front window with a semicircle on top, and you're optimizing the light or the volume coming in, the area, sorry, coming in. She had a postal service. I think it was another box problem there, and then an off-roaders all-terrain vehicle club, similar to the one with the rowing and the walking kind of.
Yeah.
Question. So I think that the ones you know are probably fine. You might look at number 3 on her worksheet because it was a semicircle and a rectangle.
Yes.
But as long as you feel pretty comfortable with your areas and circumferences.
Yeah. That one would be doing the area of the rectangle plus the circumference of the half circle.
Depending on if you're looking at perimeter area. So you're doing perimeter of one and area of the other. So you would want to do, area of both or perimeter of both, depending on what they asked for.
Okay. So
go ahead. Sorry.
I'm not sure how to find the perimeter of that semicircle. I know the area, that would just be half of the formula for a circle, pi r squared divided by 2.
Right. Same thing with perimeter. You're going to take 2 pi r divided by 2, or just pi r.
The perimeter would be just... so we have, if you have an area formula, the perimeter formula is just the derivative of the area? No.
Perimeter. Perimeter is just, the measure of the outside of the circle. So it's pi times the diameter, or if in terms of radius, it would be 2 times the radius times pi, or 2 pi diaphragm, what we call it. Yeah.
Yes. Okay. I'm sorry, that threw me off a little bit. So just really that problem from optimization, probably want to take a second look at that one. And then our tangent lines, those equations are just taking the derivative and then plugging in the points and then using your slope formula to find out exactly whatever point she's looking for and the slope at that point, or the equation of that slope of the tangent line. Does that make sense? Okay.
Yeah, the equation of the tangent line, right? Yeah.
Yeah.
At that point, yeah.
And then our related rates problems, those.
A lot of times your optimization problems are related rates problems. Or they can be. So you're looking for 2 different equations that are related so that you can take a derivative in terms of one variable. Does that make sense?
Yeah, so it's kind of like our U substitution, what we're doing now, except for taking.
Yeah, you're using substitution, yeah. In order to get it in terms of one variable, yeah.
Okay, I guess that makes sense. I'll have to.
Yeah, go back and look at the related rates ones, but.
Do you think that she'll put? I thought it was kind of interesting that she had on the test, the whole last page was just complete, just all definitions.
And yes, I do think she will. She had a worksheet on, I think I did Wednesday or Thursday's work where she said, write down all the derivative rules so far. So I'm guessing she will.
She'll have us give the definition. I kind of have, on those worksheets that she gives us when she says write down the definition of this, complete it, when she has us do those worksheets, but she doesn't give a key for the worksheets. She does for the practice problems that we do, but not the definitions or things?
That's this week. When she asked us to do the derivatives of all we learned, she gives a key too.
Oh, did she give a key?
Mm-hmm.
Okay, on a couple of them, maybe I just missed them, but I would.
No, you're right. Occasionally she won't give a key, but typically speaking, Calvin, she will, like later on, like maybe a day or two later, or give something that answers those questions.
Okay, got it.
Yeah, so sometimes you're right. She does do that, but usually within a day or two, she'll give some answers to it.
Okay, got it.
Or I have occasionally just Googled it.
That's what I've been doing. And I guess my only worry about that is saying, oh, I know Google's definition or what somebody.
I know. And you're right. Occasionally I'll Google something and I'll go, I know that's not right. And scroll down and I'll find the right answer. But if I hadn't known that it was wrong, I might have written it down.
And so that's my thing. Or if I look up on Wikipedia or Google and that says one thing, and maybe it's close to what she's looking for, but not exactly. Maybe there's a specific point missing.
Right.
Anyways, whatever it may be, that's just my kind of worry. I don't want to miss little points like that.
Very much, yeah. There's so much material she could test us on, honestly.
Okay, so I probably just should go over all the new rules that we've learned to be able to.
Yeah.
The definitions of those. So. Okay. Alrighty. Oh wow, it is 9:30 already. Tammy, sorry that I'm taking a lot of time,
You're fine. Yeah, and I can't remember where this was found, Kevin, but I did look. I have this at the front of my notebook. Derivative rules, check up for.
Okay.
And yeah, and she's just got a list of all the rules there that I think that we've done.
Okay.
And I would even think that like my math lab or something would have somewhere you're going to have written down your derivative rules and your integral rules.
Uh-huh.
So I think it's probably a good thing to have, copied down. And I reference it. I mean, it's nice to have.
Yeah. I think I saw that from last Thursday.
Okay. Yeah. Just remember that we have added, the logarithm rules. So I don't have that written on this sheet. So you want to?
Oh, yes, today. So we've added log rules.
So.
Well, we've already had exponential functions, but log rules as well then.
Yeah, log and natural log and yeah. We've had power functions. I don't think we've had exponential functions before.
Oh, does she mean something to the x as like we practice
exponential is something to the x power.
So log rules, natural log rules,
right,
and our exponential,
right,
which is not the power rule, like you said, yeah.
Right, yeah.
Alrighty. Well, that looks good for today. I know I've taken probably a lot more time than expected. So.
No, it's good. It's good because you're thinking about the exam, so am I. So we gotta.
Yeah. Are you taking it this on Thursday, right when it opens?
No, my proctor's not available till Friday morning, so I'm gonna take it Friday morning.
Well, that's good. I think I might be taking it, maybe even might go into the testing center, maybe even Saturday. I'm not sure. I'll have to see what. Got a couple other tests coming up for another one for chemistry, I believe, or a quiz pretty soon. So I want to take some time for
You're
that.
not doing it all online, right? Just
No. So
that's right, because this class wouldn't fit into your or something.
yeah,
You couldn't get into the one that was.
yeah.
Okay.
So I've just got the American Foundations and then calculus online, but able to spend a lot of time. I spend a lot of time in the tutoring center for calculus.
Oh yeah.
Yeah,
It's a hard class to take online.
definitely.
I wouldn't be surprised if some of our group is dropped, honestly.
That is probably true. If some of them haven't even responded, if they're realizing that they can't keep up. So
Yeah. Has the drop date passed now?
I thought it was kind of inconvenient, but today at 3:45 p.m.
Was the job?
3:45 p.m. they send an email today, and it says drop deadline May 10th, which is today, and
Wow.
the office closes at 5, so they left you an hour and 15 minutes to drop your class.
Okay, that's funny.
So
Okay, so you're in.
I'm all cards are on the table. I got to do it. So
Okay, sounds good.
all right.
Okay. Yeah, if you think of anything else, I think you have my text. You have my yeah, you can text me or that.
Okay.
It helps me to go over stuff too, and sometimes your questions, I'm like, oh yeah, I need to review that. Like the one that really threw me, the one where she was on an island, and what was the fastest way to get to point P on the
Yes.
I had to look up how to do that, and so I want to review that. So thank you. It helps me to remember what I need to
Get
go over because it's so much stuff.
I felt like test 1 there was a fair amount of material, but now that we just said everything that we've done, I'm kind of realizing as well that this last exam I think took me an hour and a half.
Yeah.
And this I wouldn't be surprised if this next exam takes me 2 to 2.5 hours.
Yeah, I would count on it.
Yeah. So alrighty, Tammy. Thanks for the help. I'll text you, and then we'll just plan on next week or Tuesday at 8:30 again.
Yep. Sounds good.
Alrighty, sounds good. Thank you very much. Appreciate it.
Have a good night.